Welcome students. In this class we will start off by learning about quantitative data. In the previous class, if you would remember, I explained to you about categorical data. So in this case, or I would say in this session, we will learn about quantitative data. Now, how do we define this quantitative data? Now, quantitative data are numerical values that represent the frequency. So it can be frequency. When I say frequency, that includes the observations that you come across. So let me give you some illustrations. Say for example, you are giving an IQ test to students, and there are 100 students in that particular group taking the test, and you're recording their scores. Some students have got 20, 21, 23, 28, and the maximum score is say 100. So this is the scores that students have got: 30, 31, 32, say 52, etc., so on and so forth. Now this is quantitative data because it is represented by a numerical value. Now the question comes is, how are we going to get an analysis out of it? That is the all important point, right? An analysis is required to understand the data distribution. As I mentioned to you, we wanted to perform what is called as the descriptive statistics. So with just numerical values distributed all around us, the much important challenge comes is, how are we going to draw an analysis or draw an inference from this data? So that is what I'm going to teach you when you encounter quantitative data. Now this can also have several cases. Say in this case I've given you IQ test. Say for example, the next one can be age of employees in your company. Say you got ages like 21 years, 22 years, 33, 53, 63, 65, 80, so on and so forth, right? So this is the distribution of age of the employee in a organization. So this is also an example. So this is going to be the second example. This is going to be the first example. The third example can be the speed clocked by cars. Speed clocked by cars. Say for example, there is a car which is hitting 120 kilometers per hour. There is another car which is hitting 130 kilometers per hour, and some other car can clock 151, 152, and so on and so forth. So this is another illustration that you can see. And the next one can be the heights of passengers who are taking the public transport. Say the city wants to redesign its transport system, or redesign its transport cars or transport vehicles, and it is actually carrying out a study of the heights of the people who are entering its existing vehicles. So you got people who are 135 centimeters, 150 centimeters, 151 centimeters, 160 centimeters, 162 centimeters, 168 centimeters, 169 centimeters, and so on and so forth. So this is also quantitative data. So I've given you several illustrations. So the next final one is going to be the sales. The sales of products in a store. So you got a sales of 1 million of a certain product. For it can be for a month, it can be for a week, something like that. So 1.2 million, 1.5 million, and so on and so forth. So these are all different scenarios where we encounter quantitative data. Now, as I mentioned to you, the most important thing comes here is, how do we study them? How do we, first, as I mentioned to you, statistics is nothing but collecting of data, organizing the data, and then getting an analysis of the data and then presenting the data. So all these things are required, right? And that is what makes statistics a unique area. And that gives, as I mentioned to you, there are two areas. One is descriptive statistics, the other is inferential statistics. In descriptive statistics, we understand what the data is conveying. In inferential statistics, we forecast. So in this study, we are primarily targeting the descriptive nature. So having given you that introductory content about quantitative data, I would be embarking on a data set that would allow you to better understand how exactly we could use quantitative data to perform the descriptive statistics. So let me move on to that. Now I'm going to give a distribution of data. I will draw the table first. So I gave you the list of cars. People are owning Ford, people are owning Toyota, people are owning tanks, people are owning the Lamborghinis and so on and so forth. And we distributed the data in terms of a panel like this. So let me show that panel. So this was the panel I started off. So in this case, we made a study on categorical variable with Ford, Volkswagen, Toyota, tank, Honda and Lamborghini. So you have conducted the survey and the data has been presented like this. So this is for categorical. Now along with collecting the categorical data, what you are doing is, in quantitative data, you are asking one more question. Sir, what is your age? Right? This is the all important question. You wanted to know the age of the owner. Now this is the distribution. So imagine you got 58, 20. I have successfully distributed the data, right? So this is an example. This is an illustration. This is how the data is distributed. And this is a quantitative type of data. Now, what you have to do, first and foremost, you have to organize this data to what is called as buckets and bins. You got to put the data either in a bucket or in a bin. Now you might be wondering, what is this terminology, bucket and bin? Now this is nothing but you are actually distributing the data. You take all this information and you put it in a bucket. Let us assume that you are putting in this bucket, right? This is the bucket that you are utilizing to put data in. All of this information goes here. So these are the information of 100 people and their ages are here. Now all of this data that you see here, they all are above 18 years of age. Now the question is, what inference do you make out of it, or what understanding do you get? Can you tell me? What is the understanding that do you get from this? The only understanding that anybody can get is the people who are driving cars are 18 plus years of age. That's the only understanding. You can get nothing out of it other than this understanding that whoever is you owns a car is 18 years and above. That's the only understanding you're getting from this data, and that gives nothing more. That tells us nothing more about the data, right? So having mentioned to you this, what I'm going to do is I'm going to divide this data, the data that you see here, into 3 further buckets, right? I'm going to divide this into 3 further buckets. So let me see if I can get any further understanding from this. So what is the division that I'm going to do? I'm going to take all people who are between 18 to 39 years of age, and people who are 40 to 59 years of age, and people who are 62 or 60 plus and above. Now this is further division. Initially I divided I put all the data into one bucket, I see that I get only one inference, one understanding. I don't want that. So now I am going to branch off. So this is the level of distribution that I am going to be adopting. So each one of this is a bucket. So you got a bucket like this. Okay, this is a bucket. This is a bucket, right? So probably you can, the bucket arrow, right? So this is a bucket, right? So each of these are buckets, and they hold this age group. Now 18 to 39, let us assume, so this is just data for understanding. So don't think if I were to place a number, you have to go look for that number. That number is present here. So that is the assumption that I'm working with. The assumption that I'm working here is 18 to 39 years of age. If I were to put this number, say 38 people are there. So that is the assumption. Age group of 40 to 59. How many people are there between 40 to 59? That would be, say, 46 people are there. And 60 and above, say 16 people are there, right? So 38, 46, 16. So first and foremost thing, I need to add up and find out 38 and 46. This is 14, 184, 60. Okay, 100 people. It should add up to 100 people. So now this gives me a greater level of insight into the data. 18 years to 39, 38 people are driving the vehicle. Okay, fair enough. And 40 to 59, 46 people are driving. And 60 and above, only 16 people are driving. Car users are only 16 people. So that would mean people who are treated as senior. So once a person crosses 60, he or she is treated as a senior. So 60 and above, not many people are driving. So the people who are driving the car are below 59 years of age, about 18 and below 59. So what I should do, if I were to give this data to the car manufacturer, they clearly understand, okay, these are our customers. So how are we going to target our product to this particular age group of customers? There should be a different level of marketing to market for people who are in this age group, 18 to 39, and this should be a different level. So this gives a fairly greater picture, right? Now this is level 2 of segregating or distributing the data. Now there is the next level. What I can do is I can further go up and divide the data. Now you may be wondering, why is this guy keeps on dividing data? Now there is a reason for that. Now I'm going to divide this into further bins or further buckets. So let me first draw the buckets and then I will divide the data. So 1, 2, 3, 6 of them are there. Okay, now you might be considering this to be too many, but this gives a greater insights. Okay, so this age group, what I wish to do is I would like to put all the people who are driving cars or owning a car who are falling between 18 to 29, and this should be 30 to say 39, because this is the starting point for our data. 18 years, there are some people who are 18 years of age or between 18 to 29. It doesn't matter whether there is a person in the data who's 18 or not. If in case they are 18, it's fair enough. If there aren't anybody who are 18, or if they are 19, still this interval division will work. Okay, so don't be too much introspective into this number. So this is just a division. 18 to 29, 30 to 39, and then 40 to 49, and then 50 to 59, and then 60 to 69, and then 70 and above. Now this is a greater level of division. Now 18 to 29, number of people who are driving 18 to 29. So let us assume that there are 23 people driving, and in this group there are 16 people driving. So in this group there are 22 people driving, and in this group there is 23 people driving, and in this group there are 15 people driving. And say, let me take it as 13 placed in 3. I want to first find out whether I have placed the numbers properly. So this is 16 and 39, 41, 61, 67, 77, 80, 90, 100. Okay, fine. This division is fine. Now you can clearly see each of these bins are further divided. From here, the bins are further divided into 18 to 29. So you can clearly see 18 to 29 years of age, they are driving a fairly good number of vehicles. 18 to 29 of people, they are owning 23 cars, and 50 to 59 they are owning 23 cars, and 40 to 49 they are owning 32 cars. So the major groups are over here, over here, over here. Okay, 16 is fairly fine, and this is totally, you need to ignore this. 70 plus, only 3 people are driving the car. So if you are a car manufacturer, you can target this age group, you can target this age group, you can target this age group, and you can learn, you can conduct further survey in learning about what are the interests of the people who are falling in this age group. Their priorities, people who are falling in this age group, their priorities will be different from people who are falling in this age group. Their priorities will be different. Similarly, people who are in this age group, their priorities will be different. So you need to manufacture cars which are suiting each of these age groups. You cannot manufacture a car which you have manufactured for 50 to 59 and you expect 18 to 29 years of age to like the car. So suitably you need to target them. That is what these car manufacturers are clever enough. They study the data and they suitably bring out different models. Say for example, special edition. Have you heard of this term called special edition? Why are they bringing out this term called special edition? In special edition, they will bring out say 100 cars or say 200 cars. That's it. And they will shut down this model. Why? Because 100 to 200 cars will be those 200 cars that are running on the road. They are very unique. And this special edition cars, their prices will be always high. And which age group can target this? Specifically people who are well settled in life, 15 to 59. 15 to 59 are the people who have got everything in certain place. Their life is in order. Fine. So that special edition car will be targeted to this age group. I'm just giving an illustration. It can also be targeting this age group, right? But in this age group, you will have to bring out a different car which is actually catering to their interest. So as I mentioned to you, this gives a greater insights of the data. Now the all important question is, how many bins should I have in creating? Now why do I create all these bins? These bins are required to create the histogram. Now you may be wondering, how many bins should I have? So this is the all important question. How many bins are required? Now remember, if your bins are too small, too few, then you won't get a clear picture. If there are too many, you will have only few observations to study. So too few, too many, and it will also be too confusing. Confuse a person. So you should avoid the two extremities. So that is very critical. So the next is that you have to get a balance. You have to find a balance. How can you locate the balance? By practice. By trial and error. How do you get that particular, what you call as a sweet spot? It's called as a sweet spot. Okay, that sweet spot comes by trial and error. That would mean you need to put in a lot of practice in the creating of histograms. The much important point is, creating a histogram depends on data. It depends on your convenience. How do I put it? Okay, I can just put it like this: convenience, your convenience. So it depends on the data. It can depend on your convenience. But there are some softwares that will study the data and they will create their own histogram. But that can be overridden. You can override them. You can override those softwares. So the first and foremost thing that is required in creating a histogram is your understanding and your ability to pick the sweet spot. And that would largely depend on data and your convenience. So have that in mind. If somebody were to tell you, no, histogram cannot be altered, histogram cannot be changed, no, it's all, that is fallacy. So histogram is basically, you are the creator of the histogram. You are creating it and you are the master of the histogram. So these are the basic things that are required to move on. Now you might be asking me, why do we need an histogram? Why? The first and foremost thing, it helps us to visualize the data. That is the key thing, right? I just gave you the bin distribution, how exactly we can divide the data in bins, and that gives a visualization. And visualization is the most important aspect for a creator. You want to create a product, you need to first have a visualization of what the data really needs. That's the first point. So number two is, it shows us the distribution, of the data, distribution of the quantitative data. I just gave you a table in the previous page. I showed you a table where there were simply numbers and we could make nothing out of those numbers, right? Now, how do we pick the axis, the horizontal axis? Horizontal axis, this is very important. And number 4 is vertical axis. How do we pick the axis? Remember, in horizontal axis, always, that is the variable of interest. We call the horizontal axis as the x-axis, variable of interest. Now, what is really interesting in the previous data? The most important thing that really interests us is the age. You, as a car manufacturer, would like to know the age of the people. So, always on the, if you're drawing the histogram, this is the horizontal axis, this is x-axis, y-axis. Over here, you have to put in the variable which is of interest to you. And that alone solves the entire situation. And vertical axis, obviously, that is going to be the frequency, right? So determining the horizontal axis is the all important feature of getting the histogram correct. Okay, so whenever we draw the histogram, we draw them in rectangular shapes. So they all should be in rectangular shape. So that's the default one, and you should have no spaces in between. Okay, you should have no spaces in between. And of course the height is determined by the frequency. Finally, the height is determined by the frequency. Now you can either use a frequency or you can use a relative frequency. I've already given you how to calculate the relative frequency in the previous class. Frequency or relative frequency, you can do that. So these are the all important points in getting the histogram correct. And histogram is a key feature in visualization. So what does it do? It helps us to visualize the data. It gives us the distribution of the quantitative data. Horizontal axis, always pick the variable of that interests you. Vertical axis, it's a frequency. The histograms are drawn in rectangular shape. You cannot have any space in between them. The height is determined by the frequency or by relative frequency. So that is the wonderful part of histograms. Okay, now there are types of histograms. You have to know types of histograms. Now this histogram, the first one is called as left skew. Now skew means you will totally have absence of data in one particular group. The data would not be present at all. So if I were to give you left skew, the left skew would be something like this. So this is the x-axis and this is the y-axis, right? So when you say the data is left skew in a histogram, it means on the left side you will have what is called as a tail. So the data would be like this. Okay, and then suddenly it will jump up. It will jump up like that. Okay, now suppose if I were to draw this is how the histogram will be. Okay, you see that the tail is on the left side. This is called the tail, so it's on the left side. This is called as left skew. So remember that the tail is on the left hand. So that would mean the age groups which we have presented here, they own very few cars, but suddenly there is a huge height here. So that means this age group which I presented here, they are the people who are owning large number of cars. So that is a beautiful inferences that we can get from here. So now comes the right skew. So let me draw the axis, right skew axis. So I know the space is very limited to get the right skew, but it's okay. So that data would be like this. Suddenly there will be a jump, another big jump, and another big jump. So this will be the right skew. See, the skew is, the tail is on the right hand side. So let me draw and show it to you. So this is right skew. This is the x-axis, is the y-axis. Now you see, people say for example 18 to 28, and then further on up unto say 48. This is a division, 18 to 28 and 29 to 39 or 38, 38 to 40, 38 or 39 to 50, and so on. You understand the meaning what I'm trying to portray here. People who are lesser than 50, this age group fairly taller than the people who are falling after the age group of 50 years, between 50 to 60, 60 to 70, and so on and so forth. You are able to understand this. So there is a skew, there is a tail on the right end. Now this illustration can be people who are owning motorcycles, super fast motorcycles, right? People who are very young, say between 18 to 29 or 18 to 28, those people who are in that age group, lesser than 50, they will be the people who are owning. You see, actually as the person ages, the level of purchasing the motorcycle drops as they age, because you know when the people are very young, the energy level is really high. Say for example, young boys, they like super fast motorcycles. Young men, they always prefer motorcycles which are fast and sturdy. And that's the reason motorcycles like Triumph and what else, BSA, they all became popular because of the younger men who like to, the rock and roll lifestyle. Okay, so that is about this. So I've given you type 1, I've given you type 2. Then I want to give you what is called as the next type. Now this is also one more type you have to know. Let me just place this type. I think this lesson is a little bit lengthier, so I will try to finish this off. Now this is called a symmetric type. This is called a symmetric histogram. Now this histogram will be of, it goes up like that and it will come down. Okay, so this is how the histogram will look. This is symmetric type. This is the x-axis, this is the y-axis. So the next one is bimodal. Bimodal type. So you will have heights like this, and then suddenly there will be a step down like this, and then again it will go up. So if you were to draw, the shape will be like this. The histogram shape will be like this. So whenever you come across a histogram like this, it's called as bimodal. Okay, you see that this is the shape. You got a building, a tall building, and then the height diminishes, then it hits the all point low, and then it rises up. So this is a beautiful illustration of bimodal. And then if you are making a wrong choice, if your choice is wrong, then you will get a histogram something like this. When I say choice is wrong, your division of data, if your division of data is not correct, then you will get an histogram like this. Okay. Now, I wouldn't say all the time that you would be wrong in separation of data or in the categorization of the data. I'm not all blaming person who's creating it. Sometimes it would happen that the shape would be uniform. That means in each of the age group that we have mentioned here, the frequency is one and the same. So I wouldn't say this is not possible, or I would not say that this is because of the analyzer making a mistake. In either cases, it can turn out. And there is the next final thing. There will be no pattern. There is no pattern in the histogram. You will not have any patterns. It will go up like this, and then suddenly it will go up like this, come down like this, come down, go up, go all the way up, go all the way up, come down. You see that? Can you get a pattern out of this? So there is no pattern. This is also an histogram. So this is largely happens because of the error created or introduced by the analyzer, right? So this is called as no pattern. And again, there's a word of caution. This can also be because of the data. I would not blame the person who's analyzing for this. In either cases, it can result. So vigilance is the key word. You have to be vigilant. You have to analyze. You have to reanalyze. You have to study and restudy the data. So I've given you all possible patterns of the types of histogram that you will face, and why do we need histograms also. Now what I want to do is I will give the illustration for the example that we took. So now let us draw the histogram for the data that I have just shown you as an illustration. I have given you the division for 3 bins and the age groups. So I will draw the histogram for that particular age group. Now we have taken 3 bins, right? Into 3 bins I have put in the values. So if you remember, I have given you 3 bins and the age group. Let me just show you that. This is the age group that we started with, 18 to 39, and then 40 to 59, and then 60 plus, right? So this is the division. So how exactly that this division is going to be looking, I'm just going to show you. So I'm going to divide it as 20, 40, of course 30 is in between, it doesn't matter, 50, and then 60 and 60 and above. So 20, in this group you got 38 people. Let me show you, 38 people, 46 and 16, right? So 38, if I were to take this, okay, 5 is enough, 5, 10, 15, 20, 25, 30, 35, 40, 45, that's enough. So our count will start from 18 to 39. It will end at over here, somewhere over here it will end, right? So how many cars are there? 38 cars are there. So this will be the point, 38, we drop, and then we are going all the way up, and then this is actually 39, the categorization is 39, but just to make sure that we don't have any gaps, what we will do is we will have the division like this, 20 to 40, right? So we will include that 40 years people, just the beginning of 40 years will be included. The next group of people will start after 40, so all the way to 60. So that age group has got 46, so 46 means somewhere over here. We connect that, and this age group is going all the way to 60. 60, and the people who are falling after 60 years of age and owning a car, those people are 13 in number, so that's going to be somewhere over here, right? So this should be, say, I can say 60 to 80. So let me, 60 to 80, this is 60 plus, right? 60 to 80 years of age, these are the people who will fall into this group, right? So 20 to 40, 39 or 38, this is 46 people driving the cars, and 60 to 80, 16 people. So this is the division. Now this is for 3 bins. Now you can further divide this, you can move up and scale up the division to 6 bins. So I have given you 6 bins. So what I'm going to do is I'm going to stretch this. So I'm not going to be starting, or I would say I'm not going to be using 20 to 40. I'm going to divide this into segments of say 20, 30. Let me write that down here. 20, 30, 40, 50, 60, 70 and 80. So division is 10 units. So this will include, of course, 18 years are there if people are driving with 18 years of age. So it is going to be starting here, and exactly it will end at 30. So the number of people who are doing that would be, as I mentioned to you, is 23. So let me take it as 0, 5, 10, 15, 20, 25, 30, 35. So between this age group 20 to 30, the number of people who are driving the car is 23. So that would be over here, 23. So drop a line and drop a line and 20 to 30. And because that's exactly what the data division is. See, this is the data division, right? So 30 to 40, the division, or I would say the number of people, 16 people is over here, 16 is over here, 15 and 16 is over here. So this would be the division. And then 40 to 50, 22 people are there. So that is going to be over here, 22 people. And then 50 to 60, 23 are there. So again 23. So that division is going to be like this, 23 and 60 to 70, 13 people are there. 13 people over here, same thing, 13. Okay, 13. And then 70 to 80, 3 are there, 70 to 80. So this is the histogram. Now you may be wondering, can I get a relative frequency distribution? Is it possible for me to get a relative frequency? Yes, I told you relative frequency gives us the proportion. Of course you can get the relative frequency. Now if I were to draw the relative frequency for this, we need to draw the table first for relative frequency. So how do we calculate relative frequency? The number of observations for that particular class divided by the total number of classes. Okay, so this is the age and this is the frequency and this is the relative frequency. So you find out the age group. You can just take it like this, 18 to 29, 30 to 39 and 40 to 49, and then 50 to 59 and then 60 to 69, 70 to 79. Now you may be wondering, why is this guy is starting from 30 to 39 and then over here? Because this is the first observation that is present, so I need to include that, right? So that's the reason I'm placing it here. If age group of 18 is not there, then you don't have to include this. So you can simply start up with 19 to or 20 to 29, right? But two people, an illustration I'm giving, 2 people with 18 and 19 are there, so that's the reason I'm placing it like that. Otherwise I can very well start from 20 to 29, 30 to 39, 40 to 49. And the frequency, the number of people who are using or are owning a car, you got to get that. So always make sure to draw the table. The table is important. In statistics you have to draw the table because you will have a theory exam, right? Of course you might be saying everything is software can do it. If software can do that, it will also give its own hypothesis testing and its own inferences. So you can depend on software, but only so much so. You have to check everything, right? So there are 2 levels, because remember, just because the software gives you a number, it's not taken as an inscription written on stone. It has to be checked by a statistician. This is what that makes statisticians unique, right? Because they have the ability to check the data, and that check is very critical, because whenever you're dealing with critical information, sensitive information. So coming back, let me give this frequency and I will show you how to get the relative frequency. See, for example, you've got 24 people, 15 people, 23, 22, 15 and say 1. An example. So the relative frequency in this case will be 0.24, 0.15, 0.23, 0.15, 0.22, 0.15, 0.01. So you have to add this 5, 6, 8, 11, 16 and 10 carry 1, 3, 4, 6, 8, 9 and 10. Okay, 1 should be the output here. Fair enough. So this is the relative frequency. So you draw a graph using relative frequency, right? So this is okay. This group is 20 to 30. You got to put a division here. If you are dividing 20 to 30, this is 50, this is 70, and this is 80. So 18 to 29, so that will be all the way over here. So how many people are there? 0.24. So you have to have this division. So this division would be starting from 0.05 and then 0.10 and then 0.15, 0.20, 0.25, 0.30, 0.35. So that's how you divide the y-axis. This is a division for y-axis. So 18 to 29, 0.24. 0.24 is going to be somewhere over here. So you start from here, and then 29, this is over here. Okay, the next one is going to be 30. 29. So the next division will be starting from 30 to 39. So in this case 30 to 40. So that's going to be 0.15. So 0.15 is over here, right? So put the mark and draw the histogram. And 40 to 50, 20, 0.23. 0.23 is over here. Okay. And 50 to 60, 0.22, 0.22 is over here. So you connect this. .22 and 60 to 0.60 to 70, 60 to 70, 0.15. So 0.15 is over here, and then 70 to 80, 0.01. 0.01 is somewhere over here. So that is how we get the histogram using relative frequency. So this is done using relative frequency. Okay, so students, that completes our class today, and we will meet again in the next class. Thank you.